Welcome, Dmitry. It's good to have you.
Thank you. Let me try to share the screen.
You shall be able
All
to.
right. Yes.
So the last thing I want to add, Dmitry is going to be talking to us about serverless applications in Python, as you see. Take it away, Dmitry.
Thank you. Quick check. Can you see the screen?
Yes.
Okay, excellent. So my job at AWS is a senior solution architect for academic medical centers. So what I'm doing, my work days, I'm supporting customers who are universities across the United States, helping them to do projects, different kind of projects, from research projects, development, software development projects, to large-scale production projects. So this is about me, what John just read. So we're talking about serverless Python applications today, and why we are talking about them. There are two parts to this question. One is why Python? So recently, Python is one of the top programming languages that is used for a wide variety of applications. And this is because it's considered easy to use. So you can start writing Python applications without too much background and be very successful at the very beginning. It has many libraries that cover very different parts of domains that you might need. For example, in my area, in medical imaging, there are specialized libraries that allow to work with medical imaging, CTs, X-rays, MRIs, and make it really easy. And we'll go through examples later today. It is powerful, so language has all the constructs that other programming languages have. And if you need to go from simple to very complex application, it's available for you. And the most important for me, it has a great code readability. What it means is if you are working with somebody else's code, it's fairly easy to understand what the other person meant. And in software development career, I have done this many times. So frequently we need to work with somebody else's code and understand what is there, as well as to continue developing that code. Second question is why serverless? So we'll try to answer this in the first half of the presentation. And we'll look at different aspects of serverless applications in the cloud. So the first thing is no infrastructure to provision or to manage. That means that you don't really need to worry about the servers or anything that runs your code. So you pay only for the value, so you pay only for execution of your functions. If you don't use your functions, you don't pay for that. So it has automatic scaling, as many other cloud applications do. And it's really outside of what you need to care about. It scales automatically, and it is highly available and secure. This is the part that usually if you develop a production level enterprise applications, you spend a lot of time and a lot of design effort to make application high available and secure by design. So the next couple of slides will illustrate how the management of infrastructure is important and why serverless has such an advantage in this area. So this slide shows the AWS Shared Responsibility model between AWS and customers for traditional model, where you have compute, your servers, your virtual machines, storage databases, and so on. So in that case, AWS is responsible for the infrastructure. And above the line is everything that customer or programmer is responsible for. There's a lot of stuff to manage. And it's very important that this management never ends. So you need, if you have to patch the operating systems and other components of your platform. You need to make sure your firewalls and network is secure, and so on and so forth. In the serverless environment, the line shifts significantly, and responsibility for most of infrastructure and all this maintenance work falls on AWS, and customer or programmer is responsible only for the application. So what it does, it allows you to really focus on what you do and what brings value to your business or to your application. Computing evolved in the last decade. So it started from physical machines, where when we plan to develop a project and to implement a production system, we had to guess how many machines we need to serve the capacities, to serve the users. And this infrastructure was staying in place for 5-7 years until the hardware became obsolete and had to be replaced. From that, we moved to virtual machines that gave us some hardware independence and some ease of provisioning of virtual machines. From there, we went to containers. Containers provide even more freedom in platform independence. You can deploy them in seconds versus minutes for virtual machines. And then at the end of it, there's serverless. So we'll talk about 2 flavors of serverless on AWS. One is Lambda function, the other one is containers on serverless Fargate. So those 2 choices of compute can serve 2 different tasks that you're trying to serve. If you need a long-running machine, for example, if this is a server that needs to respond to network requests, the container is the right choice. So you can run it under Fargate, which is, you don't need to provision the underlying infrastructure, the orchestration layer and cluster scaling. You just run containers on the serverless environment. Or the second option is Lambda function, which is a serverless function that implements event-driven model where you're processing events, and events could be, there are many different types of events. We'll be talking about that. For example, if somebody uploads a file on your website, let's say a photo, and you want to process this photo, so the upload event will be triggering your code. In your code, you will be processing the photo, and then when you're done, the function will end and wait for the next event when you need to process something. Serverless execution is not only the compute, it spans many different categories of services that we have in the cloud. For example, data stores. So there is a Amazon S3 object store, which is a serverless service. We also have a database, relational database, Amazon Aurora, that's compatible with PostgreSQL and MySQL. There is NoSQL database, DynamoDB. And there are many other services that are facilitating event management and integration between components and the services in the cloud that make enable your serverless code with and enriching this code with the functions that can be done through other services. This is an example of traditional 3-tier web application. On the left side, this is traditional model where we have web servers installed on physical servers or virtual machines, or then there is application layer and database service. On the right side, the same model is built on the serverless architecture. So instead of the web server, we have Amazon API Gateway that receives HTTP, HTTPS requests. And from there, we connect those requests, or we send those requests to either Lambda functions or containers on serverless Fargate, AWS Fargate. And after that, so there is Event Bridge, which is a event bus that allows you to connect multiple components to execute your logic. So your logic can be broken down into small components and small modules that each of them is invoked when you need it. So Lambda function can call other Lambda functions or talk to a container, software running in the container. And the lower level is a database, data store, one of the purpose-built databases, either the relational database or NoSQL database or other types of database, or just the storage object store, S3 object store. Looking a little bit deeper into the AWS Lambda function, the source, the trigger for the function is an event, and events can be generated by either changes in data state. For example, when something is written to the data store, to the file system, or to the object store. It could be a change in data in database. So all of them can be triggering a Lambda function. It could be a request to an endpoint, such as HTTP, HTTPS, like web request to the application, or it could be a change in resource state. So the resources in the cloud, all the physical resources, all the infrastructure in the cloud is considered and could be managed as a code. So if configuration of infrastructure changes, you can trigger Lambda function that could either invoke checks, security checks, that this configuration change is allowed. It could be also managing security events and automatically handling the all kinds of adverse events that happen on the infrastructure, including the security breaches and things like that. You can also use the Lambda functions for automation, for all kinds of automation on infrastructure, which is actually one of the very widely used ways of managing infrastructure in AWS. The Lambda function can be using multiple languages. Python is one of them. And from Lambda function, you can use other services to perform the functions that you need to perform. Those are examples of data sources, different services. They are in multiple categories. There are data stores, there are endpoints, there are configurations, and all kinds of management events and logging events. And there are message services. Now, getting to the code, the Lambda function must have the Lambda function handler. So this is the function that actually is called in the code when events happening. So this function receives two parameters, an event object and the context. So event object contains information about the event that happened. For example, if I'm uploading my photo to the S3 storage, it will contain the bucket name and the key, that basically the file name for this photo, so that I can download this photo and work with it. And context has information about the operational environment, so environment in which Lambda function is operating. So in this example, you can retrieve from there the log group name and work with this, with the log files for this that are attached to this environment. To work with Lambda functions, you can, to create Lambda functions, you can use the AWS Console. So it has a fairly simple but useful environment to with editor and all the functions that you need to deploy Lambda functions, debug Lambda functions, and connect them to events and everything else that you need to do. You can use an IDE. At AWS, there is a Cloud9 IDE in the cloud, or you can use your desktop, your computer, local computer editors, IDEs, whatever you prefer to use, such as VS Code, for example. Programming models that you can use in Lambda functions are pretty much everything that you can do in any other type of programming, including the processes, threads, sockets, everything. And you can use the AWS SDK, which is built in And from there, you can access all the services inside AWS Cloud. Monitoring and logging is also provided as part of the environment. You can display the results of monitoring. You have logs that manage automatically, and it is from the console environment, from your Lambda environment, you have access to all of this. And one thing to remember is that Lambda function is stateless. So if you need to persist any data and save any data, such as a state or data that has been generated in one invocation of the function and you'll need it later on, so you need to write it down into database or on the storage. So there is nothing that is pretty much that is passed from one invocation to another invocation. So all of that you need to store somewhere. This is how the Lambda console looks. So when you go to AWS account, you just type search for Lambda and you get to the screen. So it has an editor on the bottom. There is a button to deploy the function after you make the changes. There is a built-in test invoked. So test button runs the test. On the second tab here, you will see execution results. So there are ways, that's where you can, the tabs above, where you can set up configuration. You can go to the monitoring, that will show you the graphs of invocation and other graphs, and so on and so forth. So there is also a trigger. So this is a trigger. This is the part that tells me which trigger is triggering this function. In this case, this is S3 storage. And the code that is here is the code that I worked for one of the customers to show how to process the medical images. So when an image is dropped in this bucket, I get into this function and I can process that. An important concept is Lambda Layers. So the default environment for Lambda function in Python contains the most commonly used libraries for Python. But when I need to add a library which is specialized, in my case, this is a library that processes medical images. So I need to add it to environment, somehow to this environment. And the way to do this is to use Lambda Layers. Lambda Layers are very much shared library that I can share between different Lambda functions. But I need to build them and upload to the environment before I can run my code that uses a specialized library. So now we'll talk a little bit about the SDK, AWS SDK, and SDK is providing libraries that allow to work with AWS services and on programmatic level from your code. This is a high-level abstraction that helps a developer to save time and create a very compact code that uses the functions provided by the services. So in here, you can see different type of services, the storage, the compute, Simple Queue service, Amazon Simple Queue service, Identity Access Manager, CloudWatch, which is the logging service, and DynamoDB and EKS container service. So this is an example, 2 examples of code. The first snippet shows how to use the bottom 3 is the library for Python, SDK, AWS SDK library for Python. The first snippet of code shows how to use the DynamoDB, the database resource. So we just get the resource from the library, and then in a loop, we're looping. This is a loop on the tables in database, and we're just printing the table names, just for example. The second snippet of the code is how to use the S3 bucket, the object store. So same thing. So we are getting the S3 object, resource object, and then we can create bucket and create objects and put objects on the into the storage. So it's only a few lines of code, and you can do very powerful things with this library. So this slide talks about the tools that are available for developers on AWS. They are commonly known as CI/CD, continuous integration, continuous development. So those tools enable a large-scale software development process by organizing this process. And one of the concepts is that in order to have a reliable software development process, you need to automate all the parts as much as possible and reduce number of manual operations. So everything needs to be coded and organized in code so that we can reduce number of human mistakes and impact of those human mistakes on the end results. So these are components that AWS provides for organizing this process. There is AWS code build to build the process. On the left side, there's AWS code commit, which is similar to GitHub or GitLabs. Then there's a testing and deployment and monitoring and capturing the log files when the system is already in production. And now we will get into an example from my domain, from medical imaging. This is also a project that I did for one of the customers. In this project, we have the bucket, the S3 storage. In this bucket, we are uploading the medical images, and we want to process those images, extract some metadata, and store them in a different bucket, and then run analytics and machine learning on this extracted data from medical imaging. So the upload of an object triggers a Lambda function. So Lambda function writes logs into the CloudWatch, processes the data, processes the image, and creates some metadata. So this metadata can be used by machine learning tools. Amazon SageMaker is a suite of tools for machine learning, creating models, running models, labeling the data sets, and so on. And the second path here goes to the Amazon QuickSight, which is the analytics package that allows to create analytics and visualize those analytics with and building dashboards. So in order to use the analytics, we used Amazon Athena, which is a service that provides SQL query language on top of unstructured data. So in the bucket, we have just JSON files. We saved here JSON files, and Amazon Athena is able to create and run queries directly from this JSON files. There's no need for actual relational database to do that. So starting to create the Lambda Handler, this is the Lambda function handler. As we said, it receives the event and the context. So from there, we're extracting from event. We are extracting the bucket name and the key. Bucket name and key are the parameters that you need to get an object from S3 storage. So then we download the object, and we actually writing this object to the temporary directory. So Lambda function is totally serverless, but it does have a temp directory, which is useful for libraries that historically use the file system to read and write the files. So you can use that. So that in serverless environment, you have some limits. For example, the temporary directory is limited to 500 meg, but it's still very handy. So one of the things that we need to set up when we do the serverless, when we generally work in the cloud, is to set up roles and permission correctly. So in this case, we need to have 3 permissions. We need to have permission for Lambda function to read the source packet. We need the permission to write our output, and we need permission to also write log files. So this is an example of permissions in JSON format. So pretty much what it says here is that action get object, S3 get object is allowed for the bucket, and this is the name of the bucket, and for everything that is inside this bucket. So the next step in application is to process the data. To do that, I'm using the library, which is called PyDicom. So this is a specialized library for medical images. And I'm just loading the data set into the object DCM data. And then I can just read the fields, metadata fields from this object. Very simple. With only a few lines of code in Python, so I'm creating my JSON object, and then I'm writing this JSON object into the output bucket. So this is pretty much the whole application. As I said before, the library that I'm using is not part of the default runtime environment for Python, so I need to create layers. So the way we create, one of the ways to create layers is to create a zip file with the package that it needs to be used for with my library. So Python has a specific directory structure that you need to put in this library and deploy it. So pip3 is the way that Python is deploying the libraries. So basically, I'm deploying it in a directory with a specific name, and then I zip up this directory. So one thing to remember is most of the Python is platform independent in general, but there are some libraries, especially computational libraries, that are written in C++ and wrapped in Python. So if that's the case, C++ is not machine independent, and you need to build those packages in the environment that is similar to the one that Lambda will be working. For example, I'm using my Windows computer for my daily work, but the Lambda is running on Linux. So I need to do this in Linux in order to create a package that is compatible with Lambda function. And after that, in the console, I have layers here, so I can just click on layers and upload this zip file, and it will be available from my Lambda function. And this is the end result. So if let me scroll back to a few slides to the diagram. So what we did here, we read data from the input bucket, we processed the data, we put it into output bucket, and then we use this data in the QuickSight, which is the analytics tool, AWS analytics tool. So this is the end result, and this is a QuickSight that allows you to do interactive analytics. So in this case, on the left side are the fields, the data fields that I extracted from the images. And I do have filters here. I can change the graphs, the different types of the graphs that I can present here. I can build dashboards for other people to look, and I can distribute dashboards to other people. And this data can be updated on a regular basis. So I can do this. I can create a system which keeps getting updated automatically, refreshing the data set and refreshing the results of this. So this is pretty much it. So that's the project that I finished, and customers actually liked it a lot. So it's fairly easy. It's very few lines of code. So the total code was under 100 lines, and the results were pretty impressive. And this is all I had. So I think I'm early. It's I have more time. So if you have any questions, please let me know. So I'll talk a little bit more about serverless in the meanwhile. So one of the parts of it is the pricing, how we price the serverless execution. So there is the pricing goes by the size of the environment that I need to execute the function. So you can imagine that for different types of processing, I might need either very small compute power or fairly large compute power and large amount of memory. Usually in the cloud, when you allocate memory to the to some sort of the process, it comes with proportional size of the compute power with number of vCPUs. So the pricing is by amount of memory that you are allocating and the length of the function, how long it runs. So the maximum length of a Lambda function is 15 minutes. And every user also gets a free tier. So some use of Lambda function that is not built. So you have for a month 400,000 gigabyte seconds of Lambda function, which is free, and or 1 million requests per month, which is free tier, which is not charged. So you get charged only after that when you exceed this. So it's quite a bit of compute, and you can experiment with this. It should cover most of the experimentation and debugging of the functions. Also, if you need to create a larger application that is not fitting this 15 minutes, you can create a number of Lambda function that will be executed in a sequence, or you create a state machine, you create a workflow where one function after execution, it triggers other functions to be executed. So there is a service called step function, so you can use that in order to create this kind of workflow. And in general, the idea of breaking down a large application into small parts is very it's a good idea. Many projects that are running historically for many years, especially in my industry, they are large monolithic projects that are really difficult to maintain and really difficult to transfer to new technologies. So adhering to this small modules, loosely connected, stateless is really a good direction into creating agile applications that will be easy to maintain for a very long time. So in my view, the Lambda functions will be the future, and the serverless functions will be the future of most of the applications because of all those features, because of simplicity, because of the it forces you to break it down in small pieces, because of the pricing model, because of the nature of not having to support, create, provision, and support the infrastructure, scalability, security, and everything else. So it's really a great choice for writing new applications. So with that, I have finished.
That was great, Dmitry. Thank you. It's really great. Hey, it's the same kind of thing. I imagine the same kind of thing is available in Azure and in Google Cloud. Can you talk about comparing those services? I know it's interesting competition, but it's useful.
Yeah, well, it's you probably heard that AWS is a peculiar company. So one of the things is we don't really talk about competition, and we don't really, I don't really know much about the same functionality in Azure and Google Cloud.
Okay, great. So other questions, feel free to drop it right in the chat for Dmitry. So if we weren't going to go serverless, what would be another way to get the same functionality done?
Can you repeat, please?
Yeah, if you were talking, this whole thing built around this serverless architecture.
Mm-hmm.
What's the alternative?
Well, the historical alternative is you are creating your application, you're compiling it, you're installing a virtual machine with operating system and database, and all the components are actually installed on either virtual machines or physical machines that are running nonstop 24/7. So if you have your production application, for example, in my field, so there are applications that serve hospitals, right? Hospital maybe not a good example because the hospital works 24/7, but in many other fields, your applications run only during the operations hours, but your server is still there. So, and it's constantly in use by your application, even though nobody is using it, right? So the difference with serverless is that you only run it when you actually need it, when somebody is using your application.
Oh, yeah, very good. Thank you. All right. What are the pain points that technologists need to focus on for serverless applications?
Well, I think the biggest challenge is the changing frame of mind of people who design software and develop applications. So historically, majority of applications are monolithic, right? So it's one big piece of software. We try to do modules, libraries, and everything, but still it's one piece of software that is really hard to take apart. Serverless makes you really split it in small parts. So there's also a term that I didn't use in the presentation of RESTful API or microservices. So it's also a trend that is out there for quite a few years. I think changing the way people design applications is the biggest challenge. And then if you're already thinking that way and you know how to break down your logic and your execution into small pieces, then it's really easy. It's much easier to do create, debug, and deploy small pieces than large, huge piece. That is, you have a team, sometimes 100 people who work on the same piece of software. It's really difficult to integrate that and keep maintaining that without introducing new issues. When you work on small pieces, it's much easier to do.
Oh, yeah, that's a great answer. Thank you. Other questions for Dmitry?
I'm wondering. I have a question, kind of not technology one, because I forgot to ask our Googler, Andrea Wu, and I'm curious about how does it feel to work in the company which is creating something which didn't exist before. Creating cloud, serverless, all this technology is really, you have to think about scenarios which didn't exist. So what's the approach, how to, it's very kind of startup approach, and I'm wondering how you get into the idea, what's the next services are needed?
Well, AWS is a customer-focused company, so we are pretty much working with customers, and all the ideas, they came from the customers. So majority of the roadmaps for AWS is coming from the customer requests. And AWS works with a lot of different software developers in very different domains. So they have their own challenges for their applications, for example, financial applications versus medical applications. And those there are many challenges that have not been addressed by technologists that are out there for longer time before the cloud. And those challenges led to invention of new services and design of new services. And also, as you know, so AWS Cloud, the first customer of AWS Cloud was Amazon.com, the website, right? So the retail business. Many requests came from there as well.
This is the best case scenario when you have your internal client to serve and test everything. Okay. If we don't have any more questions, maybe we have to say thank you to Dmitry. Again, I am reminding that all our speakers are available for socializing. I mean, you can reach out to them through Twitter or LinkedIn, shared.
Thank you for having me.
Yeah, Dmitry, that was great. Really, thank you for sharing with us so beautifully. Nice to see you.
Thank you so much.
Thank you.
Maybe it's time for Multimeter survey. One more.
Yeah, so there you have it. You know, you want to just consider just, you know, put in whatever answer you'd like, and we'll see it as we go. The next talk is at 1 o'clock, and we're going to be hearing from, hold on, I have to bring
David
up the
Tchaikovsky.
Thank you, David Tchaikovsky, and he's talking about
what has been taught in K-12 schools.
Thank you. Go ahead. Go ahead, Julie.
No, we're good. Let's focus on the Multimeter right now, and we will have the speaker announcement ready for you in a few minutes. Okay.
Yeah, so 3 minutes. So take some time, do whatever biological exchange you need to do, take in some liquid, drop some out. You know, stretch your legs a little bit. We've got plenty more this afternoon to keep you entertained and educated. That's where we are.
Don't forget to hydrate.
That's right.
Checking with David already. For the crowd, what have you created that you are most proud of? It can be one word or many. Choose Multimeter link in the chat, or go to menti.com and use the code 18725603. We're really interested to hear from you, and this is real life results. What have you created they are so proud of? It can be today's creation. It can be a live creation.
Could be your kids.
Oh, yeah. Your painting. Grab the link from the chat. Play some. Short answers are recommended, but you can have it as long as 250 characters.
It's great. Thank you all. Right.
Honey. How to create honey? I'm just wondering. A plan and mean structure of house. Oh, okay. Sculpture, music, a great community. I love it. Anybody can explain me how to create honey?
Well, I could tell you, you know, you can't. The bees